So I teach the security classes here, and so this is why I try and put security up front. So we're going to talk about securing your account on the cloud. This is a picture of AWS's shared responsibility model, and I put it up there because it gives you an idea of the kinds of things that you can rely on AWS and Google to supply you, and the whole bunch of things that you're responsible for when you deploy a project in the cloud. So AWS talks about security of the cloud. This means that it's providing the physical security for all of the data centers. So an adversary can't go up to the data center, break in and steal the server that your machine is running on. But there's a whole bunch of stuff of security in the cloud that you, as the person using the cloud resources, are in charge of. And so these are some of the things: the operating system configuration, the firewall configuration, the application security, securing the customer data. The cloud provider is not going to do anything about that. You have to, when you're deploying your projects, you have to think about how you're going to secure all of that stuff. And so AWS reads you the riot act beforehand because they don't want you to come back and say, oh, I got breached. It's sort of like Capital One. Capital One got breached, and they were actually pointing the finger out at AWS for a particular. In fact, Senator Wyden is going after AWS because it's like, well, there is a configuration of AWS that makes this more vulnerable than it should be. And so where does the responsibility lie? Like, where's the liability lie when there's a data breach? Does it lie with the cloud provider, or does it lie with the customer? This is something where we'll see. We'll see if there's anything that's going to happen to AWS because of this Capital One breach. But in terms of cloud security, in this course, we're going to talk about security in the cloud, the stuff that the customer is responsible for. And we're going to talk about it in two ways. We're going to talk about it via this IAM, which is the Identity and Access Management facility. And all cloud projects have this. The other thing that we're going to talk about is security via the network services, which is not listed there, but I have some slides on that. The main thing that we're going to talk about is controlling the access to the resources by the developers, the operations team, the accounting firm, the accounting department, your DevOps tools perhaps. There's a whole bunch of role players in a cloud project, and you have to get their access control right. Because if you get it wrong and they've been given too much access, this is where you can get a breach in your application. We won't cover access within the application itself. So you have a website, it's got a SQL injection attack. We're not going to cover that in this class. That's what the web security class is about. But this is more managing the access to resources within the cloud project itself. So the way this is done, and the acronym is the same for AWS and Google Cloud, is through IAM, which is Identity and Access Management. So the first part of this is identity, which refers to authentication. So this is validating the users and the applications that are asking for resources. For the users, this is done via what you know, which is a password or a security question, what you have, which is a hardware token, or something that you have on your person, like a phone, who you are, and where you are. So an IP address or a geographic location. So this is pretty simple. For applications, the way we authenticate applications is typically through what you have, right? And in this case, the authentication is done via an API key, is one of the common ways. Or in the case of Google has these service account keys. If you are authenticating an application, so this is application to application authentication. If you are authenticating with one of these mechanisms, it's really important that you keep these keys secret, because ownership of this key proves your identity in the cloud space. So you don't want to be adding and committing these keys into your Git repo, is basically it. The other thing that's done is you can do security based on where you are. And you saw this with your database stuff. Like if you wanted to punch a hole into your backend database for your IP address, you have to add that thing to a security group manually. Okay. The other part of IAM is the access management, and this is a policy that maps a set of users to the permissions that they have to access particular resources. So there are different types. So this is a picture of it. You have some policy that takes identities and figures out whether those identities can actually access that resource on the right. You'll see there are many different ways of implementing access management in computing systems. The ones that you've seen already are the first one is discretionary access control. And in this access control mechanism, whoever owns the object decides on the permissions for the people who access this. So this is the Linux model. If you own the object, if that user ID who has created and owns that object is you, then you can set all the permissions. You can set read, write, execute on all of those files. There's also mandatory access control, where the system or the administrator decides who has access to the resources. And this is mandated in high security environments. So a lot of the government systems are done this way. So the labeling of top secret versus classified, unclassified, different levels of clearances that are required. The government, the administrator wants to control all of that. The people who produce the documents don't get to say. This is required in many government systems, mandatory access control. The other type of access control is role-based access control, where the system will decide based on the user's role, and then the role is going to determine the set of permissions that you get for access. So for example, in a cloud project, you might have an IT administrator, you might have a software developer, you may have the billing admin as part of your project. You could have a third-party tool. So say you're using some sort of CI/CD tool, and you want to give that tool some access to your project so you can actually deploy stuff. You would want to give it a role and restrict the kinds of permissions that it has on your project. You could have, if you have a contractor, perhaps, who's helping you with your database implementation, then you'd give them a role. You'd have end users with a different role, etc. And so when you have all of these different roles in your project, you want to apply what's known as the principle of least privilege. So this is what we teach you in security classes. Don't give privileges out to people unless they absolutely need them for the particular role that they have. I was just at this OWASP security training day, and I overheard a company that gave all of their developers root account access to their AWS project. That means the developer owns everything. And that's like, that's not least privilege at all. But as soon as a developer has that kind of access, they will never want to get rid of it. They'll never willingly say, no, you can restrict my access. And so they have this cultural problem in this company where they realize this is horribly insecure to have all these people with the root account access. But then, yeah, taking something away, you know how that goes. Doesn't go well. So you have to, if you are a company and you start up a cloud project, and so AWS so if you get any of the certifications in AWS, this is what they teach you up front. There's like, this is how you set up your organization so that you can do the principle of least privileges on the users that you start instantiating in your project. It has to be done ahead of time. Okay. And so the cloud is most cloud providers are using role-based access control. And so you have these roles, and then you have permissions that are assigned to those roles. And then if users are assigned the role, then they'll get those permissions at runtime. So this is managed. Well, the policy is static, but then at runtime you can figure out whether or not the permission is going to allow a particular person to have access. Okay, so the IAM policy then determines which users, the who, can do what actions in the green to which resources. And so the particular identities or memberships on Google, it's done via your Google account, so your app.pdx.edu account. It's also done with Google Groups. So if you create a group and you add a bunch of users to it, then any user in that group can access a resource as that role that you have assigned to that group. For a lot of the applications that you're going to be running, it's done with what's known as a service account. And a service account is an email address that's associated to particular resources and particular roles in your project. And so given this, these identities are given predefined roles. They can be given predefined roles with specific permissions, or you can give these things individual permissions. And so for a lot of the code labs in this course, there are these curated roles that we allow these things to take on. There are 3 curated sort of umbrella roles for any of these sort of resources. You can be the owner, and if you're the owner, you can create, destroy, assign the permissions, read, write, and deploy. For an editor, you can read, write, and deploy, and for a reader, you can just read all of the resources in that project. And then you have things like billing, where you can only go to the billing interface of that project. Okay. And then the permissions for this user are applied on any number of resources. So the granularity of what the resources are that they apply upon, virtual machines, networking, database, all the storage buckets can be resources. And so you can see that there's going to be a lot of policies, a lot of roles, and a lot of resources that they control access to. This ends up being quite a complex, this is where the complexity of cloud security is, with all of these roles and resources to have to manage. Okay, here's a picture of what's going on in Google Cloud. On the left, you have the identity. So your Google account, so this is actually a human, typically a service account, which is assigned to an application. An application would be given a service account, and that service account might have a role. So either the Google account or the service account will be given one of these roles, and based on the roles, it would also be mapped, it would be mapped for a particular role on particular resources on the right. So those are the parts of Google authentication. Here's an example of compute engine. So say I want to assign you SSH access to one of my instances. What I could do is I could create a Google group. In fact, there is a Google group for this class. I can say this particular Google group that I have, I'm going to give everybody in that Google group the instance admin role. And as part of this role, I can basically do all of this stuff. You can start and stop the VM. You can SSH into it. Once I give you this role for my project, so I would have to enable this in my project, then you can basically go into my project and get any of these. Okay? So you could do this incorrectly. I could do this incorrectly, and I could give you too much access, and then you could do things in my project that I didn't expect you to do. This is where your cloud security CTF, the Thunder Cloud CTF exercise that I'm going to have you do the next 3 or 4 weeks, that's what that CTF is all about. Giving you way too many permissions and letting you run havoc on your own project, not on mine, is the idea. Okay, so this is who. This is what actions they can get. And then this is what resources. So I would apply those on, in this case, all of the compute engine resources is what I'm applying them on. Okay, so service accounts, these are specific to Google Cloud. It gives a piece of software or an application or even a resource like a virtual machine. It gives them a role, or an identity that can be assigned a role, I should say. So this allows authenticated access that's based on a shared secret key. So when I have a service account established and I have that role and I want to authenticate using that service account, I can issue myself a key. And by presenting that key, I can take on the role that the service account has. And this is the way that you'll be doing it in your apps. In the Google Cloud Labs, this is how you authenticate your app to allow it access to, for example, in your homework number 4, like you need App Engine to be able to write into the cloud data store, because you're doing your Bubble Tea app is going to be, it's trying to write out the Bubble Tea locations into a cloud database. You have to be able to have your App Engine resource right into that. So you have to allow that access in a policy, in a role, and then you would assign that. So that's just an example that you'll be running in your homework. And there will be step-by-step instructions for you to do this, but just keep that in mind as you're doing this, that this is what's happening underneath. Okay. Here's an example where I created this service account. It's called Level SSH. Handy Compass is my web security project. And it says, I want to give this service account the role Cloud Data Store Viewer and Logs Viewer. And then if I authenticate, if I have this service account's key, then I can see the project's data store data. And I can also read all of the Stackdriver logs for this project. Okay. And if I want to use this programmatically, then what I can do is in IAM, this shows up, this service account shows up, and then I can actually issue a security key based on that service account. Okay, and then this is a picture of being able to create a key for your service account, and this is the thing that will enable your permissions all throughout the infrastructure. So this is basically the canonical way that the security is done on the back end for Google. AWS does something different, but we're mostly going to do Google. Okay. One of the things you can do with the service account is that you can associate it with a resource. So in this case, I have a virtual machine, and it's called level SSH is my VM, and I want to associate this service account to that virtual machine. So if I, for example, want that virtual machine to be able to view the data store viewer and the logs, that's basically what happens when I associate this service account to that virtual machine. The virtual machine takes on this account, and any of the roles given to this service account, now the virtual machine can programmatically access the cloud resources from. Okay. And so caution, these credentials and keys should be protected at all times. They should never see the light of day in GitHub, Bitbucket, Docker Hub, or the web. And these are all ways, leaking credentials through any of these things, this is happening all the time. And there was a paper in last year's, I think it was NSDI, where they can detect an uploaded credential within 20 seconds. I think the paper is like gone in 20 seconds. They have tools that are scanning GitHub, and as soon as they see something that looks like an AWS key, it's gone. Like it's snapped up within 20 seconds because everybody is looking for this mistake. And so if you make this mistake, you should immediately invalidate that API key, that service account key, because it's gone. You can just assume that someone has copied it out. I have the reference. I'll post it on the channel if I can find it, where this tool, it's like people are like, oh, it was only up there for 30 seconds. Maybe nobody saw it, but no, people saw it. People likely saw it, yeah.
There's a GitHub bot that automatically scans most of the main tokens, and so I accidentally pushed it, and like 45 seconds later, I got an email saying, your key has been compromised.
Okay, so GitHub has figured out a way to notify you when that happens because they know that people are, okay, excellent, yes. Okay, so yeah, that's, hopefully that never happens to you. Okay, yeah.
So if you do HTTPS and you have your key on your, is there a way for
Should be fine.
Should be fine?
Yeah. Should be fine. Yeah, you won't be able to have someone passively monitor that, pull your API key, and then go with it. Yes. Yes. That is correct. Okay, so IAM roles, we talked about the generic ones like owner, editor, viewer. These are the fixed roles that you're given. But if those are way too coarse, you can do highly granular ones. And in fact, you actually do want to do this. But here's the problem. There are so many different kinds of permissions. It's easy to get this wrong. Like this is where the cloud, we're in a world of pain when it comes to cloud security because very few people, myself included, understand what all these permissions are doing. Yet we keep putting stuff in there. So here's an example. You have an e-commerce site with a crashing bug, and the developer wants to go and access the log file. So you have a web server, yeah. So he's like, okay, you're a developer. I'm going to give you read access to this compute engine instance, say, that I have this thing on. And you have to use it to read those logs. So, okay, you're a viewer now. But by giving that person viewer access, that developer can also access all of the personally identifiable information of all the users on that site, right? And so this is where the granularity actually matters. You have to specify what parts of your cloud resource the developer should only be given access to the access logs. But like if you have all of the account information, the credit card information, they shouldn't be able to access that. Another one, you have a CI tool used in DevOps, and it's given editor access to deploy updates. This is something you want the tool to do. But if you give it editor access, it can not only update the code, but it can actually modify all your storage buckets, right? Because that's what an editor does. You can create, destroy, and edit. Well, no, you can't create and destroy, but you can definitely change all of the resources in the bucket. You can bring the compute instances up and down. You can change the network configuration. So this kind of umbrella role is not what you want here. And then if that is the case, you have to go in there and figure out exactly the things that this tool needs and no more. And this is a hard problem to figure out how to get that thing right. Okay. And so the complexity of IAM leads you to having to understand thousands of permissions and complex policies. And this is basically a mess that we have right now. One way to manage this mess is to organize it in a hierarchy. And I am going to skip that because that's not what we're doing. We're not implementing a hierarchy. There's enough in this class for you to worry about. So I'm gonna skip that. Okay, the last part of this section is billing. So I want your coupon to last, hopefully till the end of this quarter. And so for the rest of this class, I want you to periodically monitor how much money is left on your coupon. So if you go to the console, in billing, you can view the detailed charges. So if you have a computer, maybe you can go and check how much money you have. And then within that, you can see the charges this month. And you can see my charges this month. I have done a lot on Compute Engine. So the majority of my bill, $20, is because I have an N1 CPU running full time on my project. And it's basically $20 a month to run the N1. Okay. You can also, there's an interface for saying, I want to organize. So that was project level. This billing was a project level view. You can get a product level view by selecting this drop down, and then you can see which parts of the cloud platform are costing you money. So in this case, I don't have Compute Engine listed, but I've done these APIs, and this is when you know you're within the free tier. When all of that says $0, that means you're still under the free tier in terms of billing. Okay? So hopefully all of you are okay with your accounts. Always check. Don't be surprised. So this is a screenshot of a student who left their Cloud SQL. I don't have that. Yeah, their Cloud SQL. So by default, Cloud SQL launches an N1 standard. And then this is $26 later, where that thing was left up all month. Cloud Spanner is worse because it brings up 3 N1s. So I deleted the Cloud Spanner lab, but it brought up, because it wants to be distributed and replicated, it brings up 3 N1 instances, and then that thing basically is $26 a week for running that. So get used to checking your bill so you don't run out. Okay, there is a way to set up alerts if you want to get nagged. You can set a budget, say, since we have 3 months here, you can say $15 is all I want to spend per month, and then send me a message when I get to 80%, 50, 80, or 90%, and then that'll give you an alert to go back and see what kinds of resources you're consuming. This is just good practice to navigate your costs. Okay, and with that, I'm going to take a break before doing the rest of this. So I'll take a 5-minute break.